Hey everyone, welcome back for another deep dive into the world of sound and speech tech. And get this, we're looking at research that was just published today, like hot off the presses,
Yeah.
January 15th, 2025.
Yeah, it's crazy how fast this field is moving. So much cool stuff coming out all the time.
I know, right? We've got papers on upscaling old audio to AI composing music.
Yeah.
Even a new way to detect deepfakes made with the latest audio tech. It's going to be a wild ride.
It is, and it really shows how sound and speech tech is changing everything, from entertainment to security to healthcare, you name it.
So true. Okay, let's jump right in. First up, we've got a paper on something called Bridge SR. It uses this thing called the Schrödinger Bridge model, which sounds pretty intense.
Yeah, it's got a fancy name, but the idea is actually pretty simple. Imagine you have an old recording that sounds kind of muffled and low quality. Bridge SR can upscale that audio to a crisp 48 kilohertz. It's like taking a blurry photo and making it super sharp, but for sound.
That's like magic for old recordings.
Yeah.
Can I use it to make my vinyl collection sound amazing?
Exactly. You totally could. And the best part is Bridge SR is really efficient. It uses a small network, so it's fast, and doesn't require a ton of computing power.
That's awesome. They even have a demo on their website, right?
They do. You should definitely check it
Oh,
out.
I will for sure. Okay, next up we've got bio-denoising. What is that? Is it like noise reduction for nature documentaries?
You got it. It's all about removing unwanted noise from recordings of animal sounds. Think birdsong whale calls things like that.
Yeah, that makes sense. Those recordings can be super noisy, especially if you're out in the field.
Exactly. And it's tricky because we don't usually have perfect, clean recordings of those sounds. So how do you train a model to remove the noise?
Right. It's like, how do you know what to remove if you don't have a clean example?
Well, these researchers came up with a clever solution. They used pre-denoised vocalizations and samples of background noise to train the models.
So like they're teaching the model what the noise sounds like separately.
Exactly. And they tested it out with models like Dumux and CleanUnet. They got some really great results.
That's awesome. So this could be a huge help for scientists studying animal communication.
Absolutely. It could help us understand animals in a whole new way, especially in noisy environments where it's hard to hear what they're saying.
This is really cool stuff.
Yeah.
Okay, now let's talk about something a little less natural, deepfakes. This paper on CodecFake-Omni sounds kind of ominous. What's going on there?
Well, as you know, deepfakes are getting more and more sophisticated. And CodecFake-Omni is a new dataset designed to help us detect these advanced deepfakes.
So are you saying the old methods of detecting deepfakes aren't good enough anymore?
That's the problem.
Right.
These new deepfakes are harder to spot. They're using cutting-edge audio codecs that can create incredibly realistic synthetic voices.
So how does this CodecFake-Omni thing help?
It's a massive dataset that covers a huge range of deepfake models and codecs. It's like a training ground for deepfake detectors. It gives them the data they need to learn how to spot these new kinds of fakes.
So it's like an arms race. The deepfakes get better and the detectors have to keep up.
Exactly. It's a constant battle to stay ahead of the curve.
It's kind of unsettling, but it's good to know people are working on this. Okay, let's move on to something more fun. AI music generation. This paper on mode-conditioned music composition caught my eye. Can you tell us about that one?
Sure. So this research is about creating music in different musical modes. You know how music can sound happy or sad depending on the key it's in?
Yeah, like major and minor keys.
Exactly. And there are actually a lot more modes than just major and minor. Each mode has its own unique character, and the system can compose music in any of them.
So it's not just random notes. It's actually trying to capture the feeling of each mode.
Right. And it uses a spiking neural network, which is inspired by how our brains work.
That's pretty cool. So it's like this AI is learning to feel the music in a way.
You could say that. It's learning to understand the emotional qualities of different musical styles.
Wow, okay, I'm impressed. We have another paper here on music generation called Audio Agent. What's special about this one?
So Audio Agent is a system that can create, edit, and compose music. And it can do all that based on text or even video input.
Hold on, you're saying I could give it a video of like a sunset?
Hmm.
And it could create music that matches the mood.
You got it. Or you could give it a text prompt like, compose a happy song in the key of C major. And it would actually do it.
That's insane. How does it even work?
It uses a combination of a text-to-audio diffusion network and GPT-4. GPT-4 is like the brains of the operation. It breaks down complex instructions into smaller tasks for the audio network to handle.
So it's like a team effort. GPT-4 is the manager and the audio network is the composer.
Something like that.
This is incredible. Okay, we've also got a bunch of papers on speech technology. I'm really excited to dig into those.
Yeah, me too. There's some groundbreaking stuff happening in that area.
Let's take a quick break and then come back to explore the world of speech tech. Stay tuned. Okay, so we're back and ready to talk speech tech. What's caught your eye in this pile of research?
Well, there's one on voice conversion that I think you'll find really interesting. It's called AdaptVC.
Voice conversion. So like those apps that make you sound like a celebrity?
Kind of, but much more advanced. Like to
Hmm.
really change someone's voice, you need to separate the actual words they're saying from the way they sound, like their unique style. And that's what AdaptVC does.
So it's not just slapping a filter on top, it's actually analyzing and understanding how someone's voice works.
Exactly. It uses these things called adapters to dynamically encode all the little nuances that make a voice unique.
That's pretty cool. Can you give me an example of what that would sound like?
Like imagine you want to create a voiceover for a video, but you don't have a professional voice actor. You could use AdaptVC to make your own voice sound like anyone you want.
Wow, that's pretty powerful.
Yeah.
What about ethical implications? Have they talked about that at all?
They have, and it's definitely something to consider. As with any powerful technology, there's potential for misuse.
For sure.
Okay.
Okay, moving on. We've got a paper here on XPO, which has something to do with speaker verification. What can you tell us about that?
So XPO is all about making speaker verification more transparent.
Transparent. What do you mean by that?
Well, current systems can tell you if a voice matches a specific speaker, but they don't really explain why they reach that conclusion.
Oh, I see. So it's kind of like a black box. You get the answer, but you don't know how it got there.
Exactly. And that can be a problem, especially in forensic situations, where you need to be able to explain the evidence.
Makes sense. So how does XPO address this?
It breaks down speech into its smallest units, the individual sounds we make called phonemes. By analyzing those, it can identify the unique features of a person's voice and provide clear reasons why a voice sample matches or doesn't match.
So it's like giving the system a magnifying glass to really examine the fingerprints of a voice.
That's a great analogy. And that level of detail is crucial for making speaker verification more reliable and trustworthy.
This is fascinating stuff. Okay, let's talk about speech recognition.
Yeah.
There's a paper here on joint beam search. That sounds pretty technical. What's the gist of it?
So you know how speech recognition systems are getting better all the time? But they still make mistakes sometimes.
Yeah, for sure. Especially in noisy environments.
Yeah, right. So this research is all about making those systems more accurate and robust.
I'm intrigued. How do they do that?
Well, traditionally, different methods have been used for speech recognition, each with its own strengths and weaknesses. This research combines the best parts of 4 different approaches into one super-powered model.
Wow, 4 different approaches. That's a lot to juggle.
It is, but they managed to make it work. By bringing these different approaches together, they can work in harmony to better understand and transcribe speech.
That's really clever. So
Oh.
it's like a team of speech recognition experts all working together.
Exactly, and the results are impressive.
Okay, on to the next one. We've got leveraging joint spectral and spatial learning with MBA for multi-channel speech enhancement. That's a mouthful.
It is, but it's a really interesting paper. It's about improving speech quality in situations where you have multiple microphones, like in a conference call or a recording studio.
So it's all about making those recordings sound clearer.
Exactly.
Okay, but how? There's
Yeah.
usually so much background noise in those situations.
Well, this system uses something called MBA, which is a way of analyzing both the frequency content of sound and the location of the sound sources in space.
So it's taking into account where the sounds are coming from. That's pretty smart.
It is. It allows the system to separate the voices you want to hear from the background noise you don't want.
That makes a lot of sense.
And they tested it out on the CAP3 dataset, which is known for being a really tough challenge for multi-channel speech enhancement.
How did it do?
It significantly outperformed other methods.
That's great. Okay, last but not least, we have a paper on Parkinson's disease, which seems like a bit of a departure from the other topics we've discussed.
It is, but it's a really important application of sound and speech technology.
Yeah.
This research is about using speech patterns to diagnose Parkinson's disease early on.
Wait, really? You can diagnose Parkinson's by analyzing how someone talks.
That's the idea. They trained a deep neural network on a massive amount of speech data, and they found that there are subtle changes in speech that can be early indicators of Parkinson's rate.
So the AI is learning to hear things that humans might miss.
Exactly. And the results are very promising.
This is amazing. It sounds like this could be a real game changer for Parkinson's diagnosis.
It could. And it highlights the incredible potential of sound and speech technology to improve lives.
I agree. This is really inspiring stuff. So we're back, and I don't know about you, but my head is spinning a little bit. All these advancements we've talked about, it's incredible.
I know, right? It's amazing how fast this field is moving.
Like, who would have thought quantum mechanics could help us improve old recordings? That Bridge SR system blew my mind.
Yeah, that one was pretty wild. It really shows how important it is to have different fields working together.
Totally. You never know where the next breakthrough will come from.
Hmm.
Okay, something else that really stood out to me was the whole deepfake thing. It's kind of scary how realistic they're getting.
It is. It's like a constant arms race between the creators and the detectors.
Exactly. You know, it makes you wonder, what other applications will we see for this technology in the future?
I mean, the possibilities are endless, really. Think about how AI is already changing music production, or how we interact with our devices using voice commands.
It's crazy to think how much things have changed even in the last few years.
And it's only going to accelerate from here.
That's both exciting and a little bit intimidating.
I agree, but I'm optimistic overall. I think sound and speech tech has the potential to do a lot of good in the world.
Yeah, for sure. Like that paper we discussed on using speech patterns to diagnose Parkinson's disease.
Oh, yeah, that one was really impressive.
It gives you hope that we can use this technology to solve some of the biggest challenges we face.
Absolutely. So for anyone listening who's interested in learning more, we'll be sure to include links to all the research papers we discussed in the show notes.
Great idea. And who knows, maybe one of you listening will be inspired to make your own contribution to this field.
That would be awesome.
Well, that's about all the time we have for today.
Thanks for joining us for another deep dive into the world of sound and speech tech.
We'll catch you next time.